Hi everyone, thanks for tuning in for this IoT session as part of the Build 2022. My name is Olivier Bloch. I'm a PM in the IoT group, and I'm looking after our developers and engagements with the communities. Today I want to talk to you about IoT and how it powers everything from the far edge all the way up to the cloud and enables what we call the Metaverse. My name is Olivier Bloch, as I was saying, and you can find me on Twitter @obloch. Pretty straightforward, as well as on LinkedIn with the links you can see on the slide right now. So IoT is no different to other what we call intelligent experiences. Customers want to leverage these technologies in order to create value, right? And their journey when it comes to IoT is about connecting and securing, monitoring their assets, their devices, so that it can gain access, real-time access and insights to improve their business processes. But the real value is really at developing new business opportunities, growing their profitability, and so on. But before they get there and are able to transform and expand, there's a bump in the road. And that bump in the road is particular for IoT because it brings up challenges in the realm of technology, investment, and others that are pretty steep. Think about security challenges. We're about to connect things to an IT infrastructure that are running something that is not common or familiar, that is not Windows, it is not Linux. The complexity of this domain is something that makes it long to implement. You don't have the technical knowledge and eventually lack of budget to get started. Not the right staff either. So all of these are things that really make that journey up to customer value hard. And what we're trying to do is to bring down that bump in the road and that challenge curve in order to make IoT more accessible, in order for our customers to be able to get to that value. So the way we want to do that is by simplifying IoT. IoT is complex, it's expensive. It's something that requires specific skills that are not very common these days. So we definitely want to build a world-class set of well-integrated services that will balance the power and simplicity. Easy to use, but super powerful. And we want to work with partners. Having partners who develop their own solutions for specific domains that can integrate seamlessly into these services that we provide. And we definitely want to be a partner with our customers in their transformation. That's the mission at a high level for Microsoft and when it comes to IoT. And for that, we have a bunch of things going on. So that's the product portfolio that contributes to building IoT solutions for our customers. I'm not going to go through the whole collection of these services here, but I wanted to bring it up as as a proof of the diversity of the services, the different areas that we want and we cover, and also the different ways we're bringing things. When it comes to devices, we want to provide software that allows to connect to the cloud easily. But eventually, if you want to, we have OSs that you can install on these devices and run there. And we have the services on top, and we go all the way up to solutions to address verticals, keeping in mind that customers might approach technology from their perspective, which is based on the vertical. Am I in retail? Am I in agriculture? I'm going to approach things differently, whether I'm coming from one or the other. All of that with security in mind. And we see here on the left Azure Defender for IoT, and I'll talk more about that today. So that's a huge collection of products, but what are they really meant to be used for? And I want to put all of that in context of the evolution of cloud and edge. You've heard Satya talking about edge plus cloud a lot recently. And edge plus cloud is a reality, is something that is happening. And today we are at this first stage, which is creating intelligent assets and products, connecting these assets, being able to extract insights and take action on these insights. What's emerging right now is what we'll call the intelligent environments. So once you're able to connect these sensors, these devices, you are able to try and put them in relationship in your digital environment. Model what's going on down there in that digital environment to be able to make these environments intelligent. And what we're looking in the future is intelligent ecosystems. We're starting from a smart building, and we're going to go to things like smart cities, right? Where we are talking about different types of environments that are put together. That's for the future. But that's the evolution of the edge and cloud. That's what edge and cloud together will enable. So let's talk about this situation that we're in today, intelligent assets and products, so that you know what we are doing at Microsoft to help our customers get their assets connected, extract the insights that they need from these assets. So IoT, in terms of maturity as a product on the market, is at that stage, just behind the chasm of technology adoption lifecycle, which means that we believe we just passed the chasm. We just passed this wall that drops a lot of the early adopters because the technology was not worth it, because they couldn't go past the investments or the struggle that had at the beginning. We are at that very beginning of that bump of that adoption, and IoT is pervasive. Everyone wants to do IoT for sure, and that's where we're at today. And that's important in the context of what we're going to talk about today, because we understand that customers have an immediate need for things to be working, to be connected, to extract the insights, and so on. And so we need to act in accordance to that. So we need to deliver the set of products that they need to get to market fast, because we're at that stage where there's no longer any time to do 2 years of proof of concept. We need to get there. So in terms of cloud services, you know these notions of infrastructure as a service, PaaS and SaaS, and we do have an offer in the realm of PaaS that's been here for 7 years now. We started Azure IoT Hub 7 years ago. So we have a set of services that address IoT scenarios, that allow you to, by composing these services, create your IoT solutions. You connect securely your devices, you're able to do some routing of that data, some massage eventually of the data. You can secure that connectivity using the device provisioning service. You can use Stream Analytics service to do near real-time analytics on that data. You can leverage Azure Data Explorer, etc., etc. Think about all these services that you already know, and you put them in combination with a couple of these IoT services. But this is a task that is not for the faint of heart. It's not trivial, and people from the hardware world might not be super comfortable with working with the cloud services, and vice versa. Cloud services people might not be super comfortable connecting these tiny devices. And so we wanted to work on something that would actually accelerate the building of IoT solution with angles that would be both about allowing the device people to better understand the cloud, make it more approachable, and same thing for people from the cloud to better understand devices and know how to work with them. Having this, what we call PaaS, or ready-made environments for application development that allow to go faster. And you'll see what that means. So IoT Central is that. It's something that doesn't require you to deploy VMs or deploy PaaS services, then connect them together with another one and so on. It's an application that you create your own, it's a solution, it's a portal where you create your own application into and then connect the device in there. You'll see, we'll show you a short demo in a minute about that. But this is really about going really fast to a point where you have something that can go to production and can scale. So IoT Central, think of it as this gateway for your devices that allow you to connect these devices simply, visualize the data, and eventually allows you to send the data somewhere with or without modification on that data. And somewhere else could be Data Explorer, could be Synapse, could be different types of services, could be also triggering workflows in your enterprise applications. And really, that's what IoT Central comes down to. Connecting and managing your devices, visualizing, analyzing the data within a portal, which is like with a wig, super easy to use, creating dashboards that allow different types of operators or users to interact with that data, as well as secure that connectivity and the data at rest and on the move. And all of that is built on these PaaS services I was mentioning before. IoT Central builds on what we spent years at developing and offers that PaaS approach that makes it simpler. Basically doing what you would have done if you were taking all these granular services. And by being built on these services, we implement for you in IoT Central high availability, elastic scale, as well as disaster recovery. Things that if you were deploying PaaS services, you would have to take care of. You would have to be conscious of. Here with IoT Central is in the box, ready to use. So IoT Central, for those who know it, because I just made a high-level description here, is something that is getting updates regularly, like at a very fast cadence and pace. But because it's an PaaS solution, you get these updates for free. Even if you have a solution deployed, and in production, these updates will not go and break anything. They will come as additional functionalities. And here are some examples of the functionalities we've been adding since last summer. Multi-tenancy has been added in there. Data transformation on egress. So basically, before sending data to other services, we are able to massage that. So making sense of the data for a world that might not be familiar with the world of devices. Save analytics queries. This is interesting. In IoT Central, you can create queries to analyze your data, go back in time, look at the time series, and eventually extract some insight directly. Now you can save these queries, reuse them in different types of dashboards, and so on. Let me continue real quick, but I will not go into details for everything here. Data Explorer integration and Synapse integration. So that's part of the story of integrating IoT Central into a broader application. You're able to go store the data, analyze the data, and the services that are meant for that, that are designed for that. Manage identities, query API. IoT Central is not about being a black box. It's exposing APIs allow you to configure the application, add new devices, extract the data from these devices programmatically, and so on. So that's what we call a PaaS, something that is in between SaaS and PaaS, the flexibility of PaaS and the power of the SaaS application. Data transformation on ingress is something that's now possible, and you have a brand new experience in IoT Central that's just got shipped this year that you will definitely want to go to. I will show you a little sneak peek of what that is, but I definitely urge you to go and try it out for yourself. And I can continue. One thing that has been added recently, which is really neat, is the ability to support devices that don't present a model. IoT Central required, until recently, for you to create a device model, a device template, so that the application could understand the type of data, the type of telemetry, type of command, type of properties that the device would be exposing. And so you were creating that model within IoT Central before connecting the device, and the device had to respect that convention established by IoT Central in that model, sending the data in the right format. So telemetry would be that JSON field, and etc. And nowadays, IoT Central allows you to just connect the device, sending JSON packets, and IoT Central could just pass it on to storage or whatever behind it, and you will see that eventually in my demo, if I remember to show you that, you'll be able to look at that raw data and make sense of it, being able to map the data to an actual model and create it on the fly in the application. That's pretty powerful. So these are the recent functionality. I definitely invite you to go check out the link that was on that previous slide for checking all the updates. It's something like several a month, so I definitely urge you to go and check it out. So let me show you a little demo of IoT Central in action. So this is IoT Central, apps.azure-iotcentral.com. This is your landing page. You can go there right now. You don't need a subscription for that. If you have a subscription, you'll get access to the paying versions and so on, so I am connected right now. You can go back to your previous applications or build a new one. But before you even go there, I invite you to go and discover IoT Central, not by reading docs, not by going to see some videos, whatever. Just go to apps.azure-iotcentral.com and enjoy, because you will have all the information about what it is for, how to use it from that landing page. About what is the architecture of an IoT application, what is IoT Central role in there, how do you connect your devices. With a cool example I'm going to share right now is using my phone as an IoT device to connect to IoT Central. You can also manage these devices. They will explain how you can use jobs and so on to work with these devices and set the properties and configuration of these devices, and etc., etc. Everything is coming right from here. So let me actually create my first application. You can pick from pre-tuned or configured applications for specific verticals, right? Whether you're in retail, energy, government, healthcare, you don't have to start from scratch. You can leverage these pre-configured templates. But let me create a just new one. I'm going to pick the default names that are coming up here. Custom application, I'm fine with that. And because I have an Azure subscription, I'm going to attach it to my subscription. But you can eventually go free, 7 days, no commitment, up to 5 devices for free. So you can try it out for free. So let's go and pick my subscription in here. And there you go, that's the one. I have access to many subscriptions. I work at Microsoft in the Azure group. I'm provisioning the application. So here what's happening is we are deploying for you a set of PaaS services. You don't see them, and in a matter of seconds, I'm in business. I have an application that now is able to receive connectivity from devices. And I could go and create my templates and so on. We have plenty of videos, plenty of documentation for that, but experience it for yourself. It's pretty intuitive. What I want to do is connect the device in a matter of seconds. So here, I have a way to connect a new device, right? So what I'm going to do is I'm going to add a new device. And I will just use the default name here. I don't really care. I will not assign a template. But what I'm going to do is I'm going to leverage an application on my phone that I'm going to start right here called IoT Plug and Play. This application here will ask me to scan a QR code. So here the device identity has been created. What I will do is get its credentials from the IoT Central application, and I will show them in the form of a QR code. And the QR code will be captured by this application here. So it's waiting for that QR code to be scanned. I'm going to go ahead and scan it. If the lighting allows it. There you go. It is now connecting. So the application is securely connecting using the credential it got from the QR code, and will go up to IoT Central, declare its model, say, hey, I'm the type of device that is that, and then we'll start sending its telemetry and allow the operator to interact with the device from the cloud. So let's wait for it to happen. There you go. So the device is connected. And we're capturing accelerometer, like a bunch of the sensors on the phone. So it allows you to really test scenarios without a real device in a matter of minutes. I'm going to wait for the device to start showing data. And I can see raw data arriving real soon. So let me go back here, refresh the page. So now it knows it's a specific type of device. It created the various tabs. So I can see the properties for the device. I can see, an overview of the various telemetry points. So here it will have a location that is coming up, the accelerometer, the altitude, the battery level, everything coming from these sensors. And I can also send commands from the device. The device supports commands. It declared its model to the IoT Central application. I can go all the way down and say, I want to turn on the light here for 3 seconds, a couple times. It does it once, and it will do it in a second time. So right. I was able to send a command pretty quick. So I will not go into details here into IoT Central and all the functionalities because you can do it yourself. I invite you to go do that. I'm going to go back to my slides and continue my story about IoT and how it powers everything. So this is our approach to make it simpler for our customers to approach IoT, right, with that PaaS solution. As a matter of fact, if you want to go deeper in terms of control and granularity, you can leverage the IoT platform, the IoT Central PaaS is built on, right? So you're seeing here managing, visualizing, securing, everything is based on the set of PaaS services. If you need to access them, you can use them as a standalone. Create your own UI, create your own way of managing the device provisioning, and so on. But still with the same principle of connecting the devices, managing these devices, and then exporting the data for further use in your business applications. If you go that path, a huge recommendation, if you use IoT Central as well, is to leverage the brand new Azure Wellarchitecture framework for IoT. So this is an initiative across Azure Group that allows to go through an online assessment tool that will ask you questions and it will allow to provide an assessment on your architecture for your IoT solution. All of that based on 5 pillars: reliability, cost optimization, security, operations excellence, and performance efficiency. And based on this results, on this assessment, you will receive specific guidance for how to really implement your IoT solution on Azure in a way that is efficient, that is what you really need. So I definitely invite you to go check it out, AKLMS/WAF, Wellarchitecture Framework for IoT. Pretty straightforward link, and that's something that you will want to go do if you're looking at IoT platform and using these services. Device management. I want to talk about some of the recent changes, announcements, and so on. Device management is one of the things that is key to your IoT solution. The operators, the OT team, need to have a strong control over these devices, being able to configure them, being able to update them, and so on. So when it comes to device management, one of the things I wanted to bring up is the ability to use what we call Device Update for IoT Hub. It's a recent service that is now available and paired with Azure IoT Hub. It's coming from the years of experience of updating Windows, basically. And now you can exploit or use that capability of deploying and deploying these updates at scale, for your IoT devices. And that's pretty powerful. I definitely, once again, urge you to go look at that, because you can leverage that to deploy updates on devices such as Linux or Azure RTOS ones with an agent. And you'll see in a second, you can also go beyond that with Device Update for IoT Hub, because there are some specificities to the world of IoT that we needed to take care of. You can also go through gateways all the way down, proxying your updates, making a temporary copy of an update on a gateway that will be then redistributed to leaf devices. The device update for IoT is pretty powerful. So here we see the proxy updating, which I just mentioned, which is about how do you update firmwares on integrated components or external ones like sensors. You can do that and leverage the infrastructure of Device Update for IoT now through IoT Hub. You can also have multi-step updates. So when it comes to a PC, the update could be pretty straightforward. You update the OS and so on. I know it's more complicated than that. But in the world of IoT, you might need to run a pre-install script that will stop some of the mechanics, some of the functionality of the device, then work on the different partitions of your device in order to do a secure update, and then do eventually post-install scripts running. So this is part of the recent addition to Device Update, and there is more that I'm not mentioning here, but you should definitely go and check out what's there. So that was about the Device Update capabilities. I want to go into the edge side of the story now. So we talked about the PaaS and how easy with IoT Central it is to create a solution. We talked about the underlying services you can use for creating a solution. Let's talk about what's going on at the edge. The edge is pretty broad. It's everything that is basically on-premise, everything that is not the cloud, if you will. And that goes from the big servers, where you can think of using technologies like Azure Stack Edge, Azure Stack HCI. So these are like server blades that you would have on your facility, where you can run pretty powerful AI algorithms. You can store a lot of data and so on. This is very much used in scenarios where you are offline. Like cruise ship, for example, not always connected or online. You want to have this processing and storage power down there without having a full cloud on your boat. Then it goes down to smaller devices, gateway, PC class of devices that can run Windows, can run Linux. We have a flavor of Windows called Windows IoT that you want to learn about. If you don't know anything about it, it's pretty powerful and optimized in terms of SKU, but as well in terms of functionalities for this kind of devices. Then we have the microprocessor and embedded microprocessors that are smaller, that will run some Linux and some other types of OSs like Azure Sphere. And then you go all the way down to microcontrollers, where you will run code directly on the silicon or on real-time or leveraging real-time OSs like Azure RTOS. This is what the edge is about. IoT Edge is a runtime that is in the middle, that will run on the PC class of devices and up, and allows you to bring workloads from the cloud, such as AI or others, and deploy them in a controlled and managed way on your gateways from Azure IoT, from the cloud. And you need to think about IoT Edge as something that, on one hand, allows to run these workloads from the cloud on the edge, but also something that allows you to manage the edge topologies. When you have several gateways, gateway and leaf devices that don't have connectivity capabilities, this is handled for you by IoT Hub as a service plus IoT Edge. And when I say IoT Hub, I also mean IoT Central when you're using our PaaS offer. IoT Edge supports nested edge topologies. This is something that is recent. If you are using Azure IoT Edge and we're in need of this scenario, it's now available in IoT Edge runtime, where you can have nested architectures or topologies. And that's something that allows you to go through these layered networks that are out there, especially in the industry, that protect the OT and the IT from each other, I would say. And you can actually leverage or do that across networks that are ISA 95 compliant and are used to isolate the different stacks in terms of security. So you can leverage IoT Edge for going through these stacks. And as a matter of fact, you can also use that for your updates of devices. Another feature has been added recently to IoT Edge is Azure Monitor. Azure Monitor for IoT Edge allows you to monitor what's going on your Edge devices in the modules, all of that integrating to your Azure Monitor dashboarding. So it's pretty powerful, and we'll have a little demonstration soon on that. So these are the news for IoT Edge. So let's look at this demo by Micah that shows how Azure Monitor and IoT Edge work together.
Hi, I'm Micah, and I'm a product manager on the IoT Edge team. Allow me to demonstrate just a few of the things that are now possible with the integration that we've done to Azure Monitor. This integration is based on a set of built-in metrics that we provide out of the box, a new collector module, and a set of curated visualizations that are available by default. Now, to give you an example of how Azure Monitor allows you to manage your fleet, I'd like to show you how you can use alerts to respond to anomalies. A new application was recently deployed to one of my IoT Edge devices. It filters the messages from a temperature sensor before they're forwarded upstream to IoT Hub. I already had in place a number of alerts to tell me when something goes wrong, and one of those alerts checks for a high queue length in the Edge Hub component. The check for this alert watches to see if any of the message queues that the Edge Hub maintains have grown beyond what I've considered an acceptable threshold. Now, earlier today, I received this email alert indicating that one of my devices encountered this high queue length condition. Let's take a look at the affected resource and see what's going on. Under the monitoring section, I'll find a set of default workbooks for my IoT Edge devices. These present some curated visualizations that I can use. Let's start with the alerts view. In this view, I can see all of the alerts that are active across all of my IoT hubs. And right now, there's just the one. I can quickly see that on this Edge 01 device, I've hit this high queue length condition. And clicking on the device name is going to take me to a details view. In this view, I immediately see that the problem is with my filter function. It has the queue length that is growing. So if I select it, I can even see that over time, that's what appears to be happening. If we look at the sender, we can also get a sense of how the messages are flowing from the sender to the runtime in blue, and from the runtime to the parent receiver, the filter function in orange, where it doesn't seem to be receiving and processing those messages. At this point, let's troubleshoot and look at the logs. In this view, we can pull the logs directly from one of the modules running on the device to see what's happening. Now, let's check the filter function. Right away, it looks like there's a stack trace of an exception that's being thrown in the code for that module. And that most likely explains what's going on and why the messages aren't being processed. And at this point, I really need to go talk to the developer and figure out what's going on. And while this has been useful for drilling in and troubleshooting a single device, what if I want to get a sense of the health for all of my devices on my IoT Hub? For that, we have the fleet view. In this fleet view, we get a summary for the past 2 hours by default of the devices that are in my fleet. Now, this is just the current IoT Hub, but if I have other IoT Hubs, I can include those as well. I can drill into the list of devices, get a snapshot for the health of a given device, and if I need to, I can jump back to that detailed view that we saw earlier. In closing, what I've shown is available out of the box. but it can also be extended or customized to suit your particular needs. And we believe that this integration with Azure Monitor will help you get more out of your IoT Edge devices and make troubleshooting and monitoring that much easier. Thanks.
Well, thanks, Micah, for this demo. So I talked about what's going on in the cloud with the PaaS solution, IoT Central. We talked about what's going on at the edge and what the offers are and the options are broad. And one thing I mentioned at the very beginning when we're talking about the offer that we have is security. Security that is core to everything. You saw a little bit around updating devices, which is part of the security story, but I want to go beyond that with something that is called Azure Defender for IoT. So that's a solution that allows you to secure your IoT solution end to end. And that's about securing not just the devices themselves, but also securing the network that the devices are connected to, and all the way to the cloud. So you can visualize the security posture and the state of your entire IoT solution, and you have a single pane of glass to manage IoT as well as hybrid cloud security infrastructures. And all of that allows you to create alerts and trigger workflows when there is a threat detected, etc. And I'll show you how that works. Azure Defender for IoT integrates into the security information and event systems and events management systems. So you can definitely integrate that into your IT infrastructure when it comes to security pretty seamlessly. And you can work with these alerts, as I was mentioning. So the way it works is the following. So if you have an infrastructure that is, I would say, managed, going through Azure IoT Hub, you have support from within the SDKs as well as the IoT Edge runtime for Azure Defender for IoT. So that's part of the story. IoT Hub connects to Azure Defender for IoT, and the devices using the SDKs and the IoT Edge runtime contribute or are protected by default by Azure Defender for IoT. But since recently, you now have capabilities from a solution called CyberX that Microsoft acquired recently, where you can manage devices that are not managed. As in, you can add a Defender for IoT sensor on your network that will monitor what's going on the network so that you don't have to install an agent on these unmanaged devices. So no change of code in there. You just use your regular device. You add the Defender for IoT sensor, and magically, it will protect your network. And I say magically, pondering my words, it's pretty impressive what it can do. And that's something that has been built with years of experience in that domain. And I was talking about the integration with Azure Sentinel so that you can manage not just your cloud solution, but you can add, as part of this cloud solution, your IoT solution. And so you have one pane of glass for all your security across all your entire solutions. So that's what Azure Defender for IoT is about. So we have everything here, right? We have all the way from devices, connect them, extract the data, reach services to do as much as you can from these devices and with these devices, and the PaaS solution, IoT Central, to make sense of the data and expose an interface that is easy to use. Let's look at the future or what's happening right now. So cloud and edge experiences are at that stage of intelligent assets and products. We are at the emergence of what we call intelligent environments. We're starting to look at how do we model, how do we make sense of all this data? How do we correlate the data from these devices with the data from this building, with the data from these people management application and solutions, for example. And we're going towards that intelligent ecosystems solution. And that is what I would call the metaverse. We're building the metaverse. We're building that digital world that is a replica of the real one with which you can interact in real time, giving you access to new functionalities, new scenarios, and so on. So I want to really put a focus on the metaverse itself and precise a couple of things here. Metaverse has been used a lot these days by lots of companies with different meanings. And here, there's a slide that tries and draws a differentiation between different types of metaverse. I know there's one metaverse, or many, by the way. But here I want to put some tags and some namings in them so that we have a better understanding of what kind of solution and scenarios correspond to what and what I'm going to talk about after. So the consumer metaverse would be the part of that metaverse story which is about social interaction, gaming, concerts, entertainment, something which is more towards consumers, right? Enterprise metaverse is something that is in between the consumer and the industrial metaverse. The enterprise metaverse is about productivity and collaboration. So we've seen some scenarios from competitors as well as the HoloLens team about having someone virtually in a meeting room to collaborate better. You have the notion of remote assist as well through HoloLens, which is a good example of that enterprise metaverse that I'm talking about. And then you have the industrial metaverse. And this is where Azure IoT Edge, Azure Digital Twins, and other types of services that the teams are building are focused on. What we want here is to really have a software-defined industrial environment to improve complex operations. And you'll see what that means. But the focus is here on industrial metaverse and a little bit over enterprise metaverse when it comes to remote assist, for example. And the capabilities that we're building for that industrial metaverse go all the way from connecting the physical world to the digital world, to the cloud, through the IoT services I just mentioned and the edge story, then model the real world into the digital using Azure Digital Twins, and visualize, geolocate this data, these things, and so on with Azure Maps, analyze the data at scale with Azure Synapse Analytics, create autonomous systems with Azure AI and Project Bonsai, use Power Platform to automate workflows, leveraging all that data analytics that happen from that environment into your business applications, and then visualize that digital world, project it in your reality or in a virtual reality. All of that integrating with partner solutions and capabilities. So that's what we are building. And you see names of products here because these tags are things that are real. These are all products that exist. When put together, they allow you to create a metaverse for the industry here. And I want to put a little focus here. We talked about that lower stack, which is the connectivity of the real world with the digital, with the cloud. Now let's look at Digital Twin and Azure Digital Twins as a service. So Digital Twins is that service that allows to create that digital replica of the real world. How does that work? And what can you do with a digital twin, basically? So that's the question, because we talk about digital twins, we talk about metaverse, but what can you really do? So the first step is the modeling, where you're able to compile data from different sources, not just the environment and the sensors, for example, in this room, but also attach the data with data coming from the blueprint of the building, coming from the HVAC system management, coming from the room occupancy from my calendar or things like that. And create that twin, which is this room, including the sensors and device in there, including the people in there, including the environment, machines, and infrastructure. We model everything in Azure Digital Twins. That's what the service is about. And once it's modeled in the form of a very rich database, you can query that database. You can query through relationships between the entities, between the twins. It's pretty powerful, really fast, very efficient. And that's what Azure Digital Twins enable, modeling your environment into the digital world. So once you have that, it's limitless. Well, the first thing, you can synchronize your real world with the digital one. You created the model, but now you can get the data in real time. You want to display the temperature that is outside in your wall with HoloLens like we've seen? Yay. Now, if you want to see the temperature of that machine on my factory floor or the speed of that conveyor belt, you can display that in virtual reality without the need for a specific screen for the operator here. So synchronizing this real environment with the digital one is key. Once you have the data coming up, you can monitor things remotely, right? It's pretty straightforward. You can see in this digital environment what's going on. And now that you have the data up in the cloud, it's been stored in time series, so you can go past in time. You can rewind your metaverse and go back in time in your digital environment to see what was the state of this room or this machine yesterday at 3 p.m. when I received an alert that something was malfunctioning. And now it's pretty straightforward, and you can start doing correlation. Oh, at 3 p.m. I had this person come into the room, it brought the temperature down for a 30-second, and then that's what generated that alert. And you were not able to do that, but with intense scrutiny over different types of data, different sources of data, and so on. Digital twins put all that together with simple queries for you to be able to access the data and access the past data for that environment. You can also analyze. You have the data, you have very rich AI you can apply to that data, so you can start analyzing the data, extracting insights. But you can also do that for prediction. You can start creating models that will predict what's going to happen in your environment with that huge amount of data and these queries that are super powerful, plus the AI compute power you have in the cloud. You can do whatever you want in terms of prediction. You can simulate. So you have very expensive equipment in the studio. I used the room as an example. Well, if you don't want to break your very expensive equipment, you might want to try things in a virtual environment. And with digital twins, now you have a replica of your physical world that is so close to the real world that you can run simulation there and basically augment safety for your operators, reduce costs for machines, and optimizing timing as well, because your digital world might execute this simulation way faster than if you were to retry something 12th time in real life. And so that's something which is key in terms of scenarios for the use of digital twins, the simulation. Last but not least, once you've been able to study the past, analyze the present, predict the future, you can start creating autonomous control for autonomous system, right? You can start automating things and acting on the real environment from that digital world where you were able to do all that compute, all that analytics, all that prediction, and so on. Last but not least, you can now interact with your physical environment through the digital one, right? So you can access remote infrastructure and control them from where you are. You can integrate data from a remote environment into your actual real environments using HoloLens and augmented reality. So that's something which is made possible thanks to Azure Digital Twins and the other services that are available. So let's look at a little video here that gives some perspective on what is possible with digital twins, what kind of scenarios, and how it's going to shape or reshape or make our world evolve in the industry and more.
Imagine our world today. People, vehicles, businesses, buildings, hospitals, factories, entire cities, and the billions of devices that connect us to this world and to each other. This is the physical world. But what if we can replicate that physical world into its digital twin? A digital twin that is bound to the physical world in real time, that we can experience in mixed reality, that we can collaborate with, that we can run simulations on and find what is important to us, that we can apply AI to learn, predict, and act, to save time and money, to reduce carbon, to preserve natural resources, to improve safety, to bring us all closer. This is already happening today. Across the world, organizations are taking advantage of this new wave of innovation that trends to an interconnectedness that enables the metaverse. Everything modeled in the metaverse mirrors the status of its physical twin, including the interactions and relations between everything else. By applying the power of the cloud, we eliminate boundaries of what this can do. The potential is limitless. We can now track and analyze data from connected environments to identify patterns, trends, and anomalies. We can now simulate any possibility, evaluate outcomes, determine the impact of any change or condition. We can now harness AI to perceive the physical world to improve and automate tasks, to give superpowers to your frontline workers. We can now give everyone in your organization the power to build apps and workflows, to collaborate with each other in this virtual space, to share and receive expertise at the right time with the right context in front of you, to move through the physical world and get relevant information about its digital counterpart when and where you need, using mixed reality. The Microsoft Cloud brings these capabilities together with the limitless computing power of the cloud and intelligent devices at the edge, and creates this framework for building immersive and impactful digital twin, mixed reality, and metaverse solutions.
Okay, so that's what digital twins allows you to do, right? Creating that metaverse. And as a technology, Azure Digital Twins is available for you to use today. Integrate your IoT data into digital twins for then mapping and so on. I want to put some focus on one particular area here, which is the analytics. How do you analyze this complex data that's been modeled into Azure Digital Twins? And for that, we have a demo that you'll see right now that shows how that integration works.
Hi, I'm Taylor Anderson, and today we're going to talk about how to use Azure Digital Twins and Azure Synapse Analytics to find insights in the time series history of digital twins, and how to then combine that data with additional data sources. Let's first start off by reviewing the role of each Azure service in our integration. Azure Digital Twins allows us to digitally model a real-world environment and contextualize the data that comes from that environment. We can use Azure IoT to connect the real-world environment to Azure Digital Twins to keep the digital model live and up to date. And finally, we can use Azure Synapse Analytics as a common environment to combine data from many different data sources and to run analytics over that data. There are many different classes of problems that this service integration solves. The common challenge is in manufacturing, where customers need to combine and create insights across both IT and OT data sources. Consider this example. Alice is a production manager at Vandelay Industries, and she receives a complaint regarding the quality of a batch of widgets shipped to Contosa Link. The information she needs to investigate the issue is scattered across multiple systems. The purchase order detail is held in the Enterprise Resource Planning System, which is an IT data source. The manufacturing execution system holds the production schedule data, and that's an OT data source. And then lastly, the factory model and the telemetry from the stations that produce the widgets is another OT data source. Alice can use Azure Digital Twins and Azure Synapse Analytics to ingest the needed data into a common workspace, and to then combine and analyze the data to investigate the issue. Azure Synapse Analytics provides connectors that make it easy to ingest data from a wide variety of sources, including the most popular ERP and CRM packages. And with the new historization capabilities for Azure Digital Twins, Alice can also ingest model and contextualize telemetry data into the Azure workspace as well. Once ingested, these datasets can be queried and combined in Azure Synapse across both SQL and Azure Data Explorer pools. Let's look at how Alice can combine and analyze this data in Azure Synapse Analytics to get to the root of her quality issue. Recall that Alice has a purchase order ID. She can use that purchase order ID to perform a lookup in the purchase order table to identify the plant code of the plant that was responsible for manufacturing the widgets. She uses that plant code to then look up the appropriate production schedule. With the production schedule, she now has the plant code and the manufacturing line responsible for manufacturing those widgets. With the plant code and the manufacturing line IDs, she can then perform a graph query to identify the stations responsible for manufacturing the widgets. In this case here, she's going to run a graph query based on plant 3200 and production line 2 for that plant. That query will return the digital twin IDs for the CNC machine, the conveyor belt, and the robot that manufactured the widgets. Once she gets those twin IDs back, she can then filter the data history from all of her digital twins down to just those specific twins and look at a time range specific to the time of manufacture for that purchase order. Lastly, she can take the time series data for those digital twins and use Azure Data Explorer to analyze the time series data. For example, she can use the ADX anomaly detector to automatically search for anomalies in the time series data from those twins. Now that Alice has all the needed IT and OT data in the same workspace, she's built a dashboard to streamline her investigation. When she selects a purchase order, the dashboard automatically identifies the plant and the production line responsible for manufacturing the widgets. The dashboard then charts the telemetry from stations on that line and automatically flags any anomalies in the time series data. Upon inspection, Alice sees that there was a spike in the power consumption of the conveyor belt on the line that fulfilled the Contosa order. She now has a lead on the cause of her quality issue. All right, well, that's our summary of the integration between Azure Digital Twins and Azure Synapse Analytics. We can't wait to see the applications you build using this new integration.
And Digital Twins is not just about Microsoft and what we're doing here. It's important that this is something that we work with the industry on. So there's this Digital Twins Consortium that we co-founded as Microsoft and work with co-founders up there like Dell and GE, because we think it's important that we think about digital twins as a technology and the underlying language, which is called DTDL, as something that is an industry standard, something that everyone can use, everyone can contribute to. And so if you're interested in learning more about the Digital Twins Consortium, just search it online and go learn more about it. This is definitely an industry effort. And that's all I had for you today. I hope that was enlightening and that you know a bit more about IoT and what Microsoft is doing around IoT and how IoT is definitely powering everything from the edge all the way up to the cloud and help creating that Metaverse thingy. If you want to learn more, once again, go try it out for yourself. Go play around with Azure IoT Central to learn more about how to connect the device, integrate the data into Azure, extract the insights and so on. So that's apps.azureitcentral.com. Also, you can go and check out the IoT show, which is a show I have the chance to host, which is all about IoT. So technical demos and information about the latest on IoT, as well as our technical blog, msiotblog.com. Once again, thanks for watching. Hope to see you soon. Bye.